Hi everyone and welcome back to my channel. For those of you that are new here, my name is Ellie and I'm the founder of Code of the Future, and today we're going to be continuing with the Rust course where I'm teaching you all about Rust for beginners. Before we dive into the tutorial, make sure you give this video a big thumbs up and subscribe down below if you are new to the channel. But with that said, I'll put my glasses on and I'll move you onto the screen. Okay, so in the kind of aside video that I did previously, we looked at VS Code and how you can set up Rust in VS Code. If you missed that video, don't worry, there's nothing new that you need to know. It was just a bit of an aside if you fancied coding in a different IDE than Sublime Text. But yeah, as I said, you don't really need to know much about that. The proper previous video that we did was tutorial 6 and we looked at data types. So we looked at why data types are so important in Rust and why you need to be very careful using certain data types because sometimes we come up with errors. And that's kind of briefly what we touched upon here when we were saying we have maximum and minimum of certain I64 or I32. I also noticed that here we changed this from an I64, so a 32, sorry, the other way around, and just because of the text here, I'm just going to change that back to an I32. So that should all be amended in the GitHub, which, as I say in all of my videos, there's code, all of the code that I write on this tutorial series is on my GitHub, and the link is in the description. Okay, so we looked at data types and why they're so important. We're going to touch a little bit upon the effects of certain data types and overflow, which is kind of something that we touched upon briefly last time here in this section, but we're going to dedicate a whole tutorial to it. So I'm just going to cross off this main file and we're going to open up our brand new tutorial 7 main file. Okay, cool. And we have our terminal set up here, so if I do a cargo run, there we go, hello world. Now something that I have kind of forgot to mention in some of my videos, I've just done it by default and not mentioned. If you actually press the up arrow, the previous command that you wrote in your terminal pops up. So that's just a bit of an aside for those of you that aren't used to working in terminals. Up does the previous, and then if you click down again, it will go to where you are now. So if I just press up, cargo run it, and then we can enter. But I'm sure most of you, or at least I hope most of you all know that. If not, don't worry, it's just a kind of handy feature. So I'm just going to clear this, and what we're going to do today is some basic arithmetic, so some basic maths. Don't worry if you don't know much about maths, this is going to be very, very basic stuff. So we're going to start by saying basic maths, and I'm going to remove this line here because we don't need to do any printing of hello world. We're going to assign a variable, so a, and we're going to let it be 13. Choose whatever number you want here. It can literally be anything as long as what we're talking about works. So preferably go for a higher value, so I'm going to go for 9. 13 and 9, awesome. So we have our basic maths. We have two variables assigned. We have A and B. Now by default, these are I32s. So I'll just put that here by default. In fact, I'll just leave it for now. We know that they're going to be I32s, and that's just what happens by default. And what we'll do, instead of having them as I32s, we're going to make them into I8s. And this is how we assign that variable. In fact, do you know what? I'm going to make one an I8 and a U8. And I'm just going to show you something that happens when you have two different variables, both different types. So here I'm just going to put the range. So the range that an I8 can take, if you remember from the previous video, is 128 to 127. And here, it's 0 to 225. There we go. Now, remember that if I was to put a value here that was like 128, because that's out of this range, we'd come up with an error. So if I was to save this, so it keeps asking me to purchase Sublime Text, but I don't need to. We're just doing free tutorials. Cargo run, enter. There we go. We have an error, and again, it says literal is out of range, which we did in the previous video. We know that happens. So let's move it back to, I don't know, what did I have it as before? Was it 13? We had it as 13. Okay. Now, what I didn't mention in the previous video, just because I wanted to touch upon it today, that is what is known as an overflow, when you have a number that is out of the range for that specific data type. So again, in the previous video, we looked at finding the maximum and minimum values of a specific data type, so an I8 or an I64 or a 32, etc. And if you put a value that is out of that range, then that is what is known as an overflow. So I'll put that as a little aside here. If you assign a variable to a given data type, but that number is out of the range for that data type, then you will get an in fact I'll put it on the next line, overflow, which we don't really want. And I'm just going to put this at the top because we're going to do a bit more kind of coding down here just so it's a bit easier for you to see. Okay, so that's just something we learned in the last video and something that I wanted to mention again in this video because it's very, very important. Now, the question is, we have two different data types. We have one that's an I8 and we have one that's a U8. What do you think would happen if we added these two values? So what would happen if we added an I8 and a U8? So pause the video. Knowing that Rust is quite a complex language, what do you think would happen? So let's do that. Let's say let's C equal A plus B. I've got my semicolons in place, and all we're going to do is print line, and we're going to just print C. So let's save that. We'll cargo, in fact I'll clear this, and we're going to cargo run. Aha, so this says expected an I8 and found a U8. So B, it's hoping that B is an I8, and that's because A is an I8. So ideally, Rust wants you to add two values together that are the same type. And there, no implementation for I8 and U8. So we can't do it. So I'll just put that. We would get an error because they're both the same type. So that's something that's a little bit frustrating in Rust. You can't add an I8 and a U8 together. Similarly, you can't multiply them together. They have to be the same data type. If we change this to a U8, and again, we'll just change that range because now it's a U8, it'll have the same range. We'll cargo run when I eventually find where to type it. And there we go, 22. It does it perfectly fine for us. Cool. Now something to mention, this is also the same for floating types. So if I change this to 0.0 here and change that to an F64 and that to an F32, save them and ran, we get an error again, and there's no implementation for F64 and F32. So again, have to be the same type. That's just a life lesson in Rust and something that you'll get used to the more that you code in the language. So what about other operators? Now I briefly mentioned that the same would happen if it was another operator, so let me just copy this down here and I'll change it to a multiplication instead, and we'll call that D. Okay, we have 13. Change that back to being integers, not floats, because we would get an error otherwise. So they're both U8, 13 times 9. Okay, so what I'm going to do is I'm going to make this value to 1, and that's just because it's a small value. And we're going to cargo, in fact, I'm just going to comment out the printing of 22, we don't really need that. I'm just going to cargo run and see what happens when we multiply these two numbers together. Okay, so we get 9. That works perfectly fine. And you may think, oh, cool, so I can multiply two data types that are the exact same data type, I guess, and it will work perfectly. But when I then change this value to, okay, well, U8 has the range 0 to 225, so I'll change it to like 112, for example, and we try and multiply 112 by 9, making note that A and B are both U8s. If I cargo run, we have an error, and it says attempt to multiply with overflow. So what happens is you try and multiply two values together that are both U8, and if that multiplication is out of the range for a U8, so it's not in 225, between 0 and 225, it won't work. So this is kind of a little bit of a pain with Rust. You know, we understand why Rust does it, and it's a really cool feature, but when you're beginning it can be quite frustrating because you're trying to multiply certain values together and then there's an overflow and it doesn't quite work. And you'll understand now why a lot of the default values in Rust are I32s and the larger range, because I think Rust thinks, well, if you're going to be multiplying numbers together, they're not going to be over a certain range. So if I was to change this to a well, let's do a U32. Change that to a U32, and we cargo run. There we go, 1008, and that's because 112 times 9 is 1008, and that's within the range for a U32. So I'm just going to change that back to a U8 for now, and we're just going to make a little comment and just say, if the multiplication, so this is for multiplication, so if the operation, the result, sorry, I'm getting my words caught up here, if the result of an operation between two variables, brackets, of the same data type, exceeds the range of that specific data type, then we get an overflow. We don't want this. We really don't want an overflow because it doesn't work otherwise. So I'll just put a little comment down here and say, typically we don't want to be overflowing. To account for this, make variables larger bits, I guess. And what that means is just assign them to I64s or U64s, just to account for that overflow. Now, continuing with this theme, we also have, I suppose, division. So if I say, okay, well, let E equal A divided by B. What are our values again? 112 and 9. Let's do 93 because we know 9 doesn't go into 93. Okay, so we've done that. So let A, just realised I need to put semicolon there. Let E is A divided by B, and then all we're going to do is just print that. Ooh. Now let's think about this. So dividing 93 by 9. Okay, so we expect to get 10 plus change, don't we? We expect, 9 goes into 90 10 times, and then 3 divided by 9, that's a third. So we expect to get 10.33. I guess I'll put expect 10.333. That's if my math is correct. I did a degree in math, so let's hope I'm correct. And I just cleared the screen so it's a bit easier to see what's going on. Cargo run, okay, we have just some warnings that don't really matter. But we get 10. So, we've taken two integers, two U8s, and we expect to get 10.333, but we get an integer back. And that's what happens in Rust if you take an integer or a specific type. When you perform an operation, which is what we said here, when you perform an operation on those two types, you'll get that exact type back, which is why we don't get a float, because we didn't input floats. Whereas if I now change this and say, okay, well, this is going to be an F, so F32. Remember, for floats, there's only F32 and F64. And we're just going to add .0 in the end, because that's how a float is defined. And then everything else should be okay. Save it. Cargo run. There we go, 10.3333. My maths was correct after all. Yeah, so that's really worth remembering, is if you have two specific data types, so two variables that you have, and they're both assigned to the same data type, when you then perform a mathematical operation on those two data types, it will return the same data type those variables are. It seems like a mouthful when I explain it, there's a lot going on, but yeah, you have to be very, very careful. So if you're expecting to get some decimals out, the variables that you have, they need to be floats, just so then you'll get a float in return. So we've looked at data types and the impact specific data types in Rust has on arithmetic. Now what I'm going to move on to is something known as typecasting and conversion. And we're going to look at how you go about adding two different data types, how you go about taking two different data types, adding them together and not having an error. So just put how you go about adding values of different types. What I wanted to mention was a lot of the time in Rust, you won't actually, specifically state the type of variable you're using. So realistically here, we said, okay, well, F32, we're going to make A an F32. But if we omitted that and didn't, assign it, Rust would do that automatically for us. So in the case of, A plus B, Rust usually assigned its variables to a larger data type, so I32, and that accounts for things like overflow. But in the situation where you do want to add two different types, sometimes you could be doing data analytics and you could have an entry of a specific column. You could have two different entries from an Excel sheet, let's say, and one of them could be an F32 and one of them could be a U8. What happens? So now previously we've looked at assigning types. So simply we've said, well, let X be a U8 and that's going to be value 9. Now there are different ways of assigning, so I'm going to call that number 1. You can then do, okay, well, let X1. I'm going to call that X1, call that X2. And instead of doing what we did above, you can have the number that you want, and then next to the number, you just put what you want. So a U8, and that also makes 9 a U8. You can also have method number 3, which is where we'll let X3 equal 9, and that's going to be as a U8. Okay, so these are 3 different types, the 3 different ways of assigning your type. This is the one that we've looked at, but these 2 also come in handy, and I'll explain why that is now. So here we're treating 9 as a U8 data type, which is what we do in all of them. In fact, I'm just going to put, we're familiar with number 1, this was meant for number 2, my apologies. So here we're treating 9 as a U8 data type. Now, something to mention, you can actually put an underscore in here. Rust has this really handy feature of saying, if you want to let, let's, instead of a U8, let it be a U64, and say we have 900,000. Rust has this awesome feature where an underscore is just blanked in Rust. So say you have like some huge number like that, and you just want to, keep track of the thousands, then underscores, that's how underscores work in Rust. So it's quite handy. So here, this underscore does get ignored. It makes your code a little bit neater. It looks a bit nicer than that. But yeah, that's just a side note that you can do underscores in Rust, and Rust just ignores them, really. So here we're treating 9 as a U8 data type, and here this is also how you do explicit type conversion. I'm just going to let that run over because, yeah, we know what's going on here. Okay, so you may be wondering, why have I mentioned this? Yeah, Ellie, why do I need to know this? And it's because this handy number 3 method, third method here, helps when you add certain values together. So let's go back to saying let be 113.0, and that's going to be an F64. Now I'm going to let y equal 5, and that's going to be an I8. So here are 2 different ways of assigning it. Now I'm going to let z equal x divided by y, and if I was to print line and find what z was, now I'm just hoping that nothing here will pop up with an error. I'm gonna, not clear, gonna cargo run. Okay, we have an error, and that's just because I haven't added a semicolon, but that's fine. The other error says down here, no implementation for an F64 divided by an I8. So again, the issue here is we have 2 different variables. One's an F64, one's an I8, both different data types. We can't, perform calculations. But what you can do is we can say, well, we know that X is an F64, so what we need to do is change Y into an F64 so we can perform this operation. And the way that we can do that is simply say here, Y as F64. Now, I like to put parentheses round, things like this, just because it helps, but you'll notice there's a little squiggly line underneath, and that's just because Rust will tell us we don't need the parentheses, the brackets. But yeah, if I cargo run, hopefully everything should work out all right. There we go, 22.6. So this is how you'll change a specific variable later on. So you could start by assigning y as an I8, and then later need to perform some arithmetic and then change it here, like we have done here. So that is what is known as casting. So typecasting. So casting y into an F64. When performing typecasting, make sure to take the number with the least number of bits and change it to the type with the most number of bits. This helps avoid errors and overflow. So again, you know, say this wasn't division, it was multiplication, and I decided, okay, I'm going to change that to an I8. That multiplication wouldn't work because it would overflow, as we saw previously. So that's just something really important to remember, just when performing typecasting. Now, the final thing I'll say is you have to be careful with Rust, because sometimes overflow occurs and Rust doesn't catch it. So Rust doesn't notice it. So this is why it's really important when you are, if you're performing any, you know, arithmetic or mathematical calculations, to just do it this way. You know, take the number that's the smallest and convert it to the variable that's got the largest number of bits in its data type. Okay, awesome. So that has been typecasting and conversion and just learning about overflow in Rust. So that was the video today. I hope you enjoyed it. If you did, then please give this video a big thumbs up. Subscribe down below if you aren't already subscribed to the channel. Comment if you fancy commenting. I also have a donation page and a Patreon set up for exclusive behind the scenes footage, if you fancy checking that out. But yeah, as I said, thank you so much for watching. I'll see you all in the next one.